attending any conference, it's incredibly important to be there. That's kind of the only way to really dedicate your time to be there and kind of be immersed in the whole thing and not distracted by other stuff going on, even if you do get distracted with interesting conversations in the hallway.
Hi, my name is John, and I'm going to be talking about crafting CUDA-compatible C++ code. So basically, the problem is I'm trying to write a parallel math library that needs to run on the CPU and GPU, but I don't want to write anything twice, and I don't want CUDA features in my C++ code, or CPU code. So just as a simple example of an operation you want to parallelize, single precision AX plus Y, it's an embarrassingly parallel problem because every index is independent of all the other indices. So if you want to parallelize this on a CPU, you get your vector of threads, and then you distribute the work to each of the threads. Or if you want to parallelize it on a GPU, I've implemented a grid stride loop in a CUDA kernel. But the issue is those were both single purpose functions that you had to write both the operation and the parallelization method every time. And ideally, we want to separate concerns into the operation and the parallelization method. So step one, obligatory, Constexpr, all the things. So the reason this is important is because on NVCC, the NVIDIA compiler, you can pass the experimental relaxed Constexpr flag, and that allows all of your Constexpr functions to be used on both the host and the device. You write it once, and you don't actually have to use any CUDA keywords. So if you can read that. So up at the top, we have the single precision AX plus Y as a Constexpr function. And so that is being called from both of the parallelization methods, the one that's doing the CPU threading, and then the one that's doing the CUDA kernel. So step two, basically you want to follow the example of the STL, pass in an operation instead of having to call it from each of your parallelization methods. So we're going to pass the operation as a runtime parameter, and the parallelization method is going to be parameterized on the type of the operation. So yeah, now we're able to pass in the CppCon to both of our parallelization methods. And so now we have separation of concerns, and everything is only written once, except that this doesn't work. So anyone know what's wrong with this? So the problem is that the operation kernel is being passed at runtime, and so it doesn't actually correctly resolve as the host or device version of it. So the CUDA version is actually getting the host version of the function. And so the CUDA kernel is going to silently fail when you try to call it. So actual final step, make the operation a non-type template parameter. That's going to force resolution at compile time. And so the host version gets the host code gets the host version, and the CUDA code gets the CUDA version. So this is what that looks like. Still just a Constexpr function defining the operation, but now we're passing in the operation as the template parameter, not as one of the runtime parameters. And so this works now. We did it. We now have a way of executing parallel operations that work on either the CPU or the GPU without having to write anything twice and without using CUDA in code that's meant for CPU. Thank you.